Hello everyone, this is Vaishali Kikan and we are discussing the measurements and data processing unit. So we are going to start our discussion with the first question, which states the NMR spectrum for a compound with molecular formula C4H8O is shown. Deduce the structure of the compound. So now NMR structure is shown. With the help of NMR structure, we are going to deduce the structure of C4H8NO. Right, so we are going to see the vertical heights of the steps in the integration trace. So now you have your books and you have this diagram and you can measure the height. So vertical heights, if you measure, it would be 1, 1.5 and 1.5 centimeter. Now these are not the whole number. So how I am going to make them the whole number? By multiplying by 2. I am going to get 233, which are the ratio of the number of the protons and which tells me the number of hydrogen atoms. The number of protons is equal to the number of hydrogen atoms. So protons is equal to hydrogen atoms. Total number of hydrogen atoms would be 2 plus 3 plus 3, which is 8. And the formula also it is given as 8. So the number of hydrogen atoms are 8. Now coming to the chemical shift, that is 2.4. At the chemical shift 2.4, you can see the signal split into quartet. So when the signal split into quartet, the number of hydrogen atoms in the adjacent carbon would be 4 minus 1, that is 3. In this manner, we can analyze the full NMR spectrum and we can make this chart, right? So we can see the chemical shift in the ppm, which is 2.4, 2.1 and 1.1 from the NMR chart. Now, the number of protons in the environment, we have seen it 2, 3 and 3. By splitting also, we can see the splitting is quartet, singlet and triplet. By seeing it, we can find out the multiplicity. For the quartet, the multiplicity is 4. For singlet, the multiplicity is 1. And for the triplet, the multiplicity is 3. And the number of protons on the adjacent carbon atoms would be the multiplicity minus 1. So it would be 3, 0 and 2. Now if I see the peak at 2.4 ppm chemical shift. So at that time, if I see this and the peak at 1.1 ppm chemical shift, so at that time I can understand this to be ethyl group. Now here we have the singlet due to the 2 hydrogen which is splitted by the 3 hydrogen on the adjacent carbon, and signal due to 3 hydrogen is split by 2 hydrogen on the adjacent carbon. So now here 4 carbon atoms in the molecule, but we have only 3 peaks. You can see the NMR spectrum. Here it is given in the formula that we have 4 carbon atoms in the formula, but in the NMR spectrum we have only 3 peaks, right? So 3 hydrogens that have no hydrogens adjacent C, right? So which means we have a carbon atom with no hydrogen attached, right? A carbon atom is present in which there is no hydrogen. So we can now deduce the structure. C4H8O will be having fewer hydrogen atom than alkane. So there will always be a double bond also. Double bond will be present. A carbon is present with only the oxygen and no hydrogen atom. Also the double bond is also present. So we can reduce the structure. It is CHHH, and here again it is connected with C, which is having 2 hydrogen connected, which is connected to C, which is connected to oxygen, which is having C triple H, right? So here we can see we have singlet, this is quartet and this is triplet. Now finding out the chemical shifts. So if I see this hydrogen atom, so this hydrogen atom is having carbon which is connected with 3 bonds. Now here the shift is, chemical shift is 0.9 to 1.7 ppm. Now for this hydrogen atom, chemical shift is 2.1 to 2.7 ppm. And now here for this hydrogen atom, so for here this carbon we have delta is equal to 2.4 ppm, right? For this hydrogen we have 2.1 ppm as delta, and for this hydrogen we have delta is equal to 2.1 to 2.7 ppm. So we can justify it from the structure as well. The chemical shifts are also justified if I see the NMR spectrum. Coming to the next question, it states the NMR spectrum for an ester with molecular formula C4H8O2 is shown. Deduce the structure of the compound. So again we are going to see the various chemical shifts and we are going to measure and trace the heights. So with the help of heights we can now again get the whole numbers, the same process that we have done, and now we can find out this chart. So in the chart we can find out the chemical shifts which are 4.12 and 1.3. The number of protons in the environments are 2, 3 and 3. So here again if you calculate the total number of hydrogen, it would be 8, and here also it is given as 8. Splitting is quartet, singlet and triplet, and multiplicity for quartet is 4, singlet is 1 and triplet is 3. The number of protons on adjacent carbon atoms are 3, 0 and 2. And with the help of this, we can propose two esters. One structure is CH3, CH2O, CO and CH3. So another structure is CH3, CH2, COO, CH3, right? So now in this in these two structures, we have delta is equal to 2.2 to 2.5 ppm for this bond, right? For this hydrogen, if I see, the delta will be 2 to 2.5 ppm, and here if I see this hydrogen, and for that delta would be 3.7 to 4.8 ppm. Now we are going to see the singlet in the spectrum at delta is equal to 2 ppm. So we saw the chemical shift 2 ppm, and there we have the singlet, which means the left diagram, ethyl ethanoate is the possibility, right? This is the possibility, right? And now if I see the various chemical shifts, so here you can see for this we have delta is equal to 0.9 to 1.7 ppm. For this hydrogen we have delta is equal to 3.7 to 4.8 ppm. For this quartet we have delta is equal to 4.1 ppm. And for this we have, this is a singlet, so here we have delta is equal to 2 ppm, and for this hydrogen we have delta is equal to 2.2 to 2.5 ppm. So in this manner we can justify the chemical shifts as well. I hope you understood all of the things. Thank you so much.